Okay, so I've been at this game a long time. I worked at IP Sharp Associates for 20 years, sort of 68 basically to 87. And shortly after that, I then formed J Software with Roger Huey and Ken Iverson a little bit later with Chris Burke. And worked having a wonderful time with that for 20 years. At this stage, my feeling is that J, as a computer language, essentially it's a mature, established product. It has a life of its own. And I don't feel sort of the need anymore to be involved in the day-to-day guiding of it as a product, as a technology, as a tool of thought. And I think probably more to the point, I've come to understand that I have a long attention span, but it's roughly 20 years. So I did 20 years with APL, I did 20 years with J, and I'm now ready to commit to, in my world, the next best thing. And fortunately, I mean, just incredible luck, so right around the 20th anniversary, the next best thing landed in my lap, which was a database system that, as Gitta said, was built over years, completely unbeknownst to us at J Software, and we really stumbled across it, completely by accident. So, and one of the interesting things is that during these different careers, APL, J, and I'm hoping now with this Vstar database, I've always worked one way or another with Morten Gitta and many of the other people in this audience. And I have to say, I've enjoyed it enormously. It's been a privilege and a pleasure. And I'm hoping that that relationship, that very healthy give and take, sharing of ideas there, I'm hoping that that relationship can continue through the Vstar phase of my life, and obviously the continuing APL phase of your lives. So deep, deep thanks to Morten Gitta and to the Dyalog community, because it's been 20 years since I've talked to APLers. And it used to be my bread and butter. So it's a joy to be doing that again. So first, a quick word. Now I'm going to get into actually talking about Vstar, which is a database system from a company called Vectornova. And first, a few quick words about the setup and the way I'm doing this. Essentially, I have my Dell laptop here running Windows 7 64-bit operating system. It's running as a server, and it's running a J engine. And on top of that J engine, there's an application level, which is a very simple, very, very simple web service. And it's also another application level, which is a very, very simple Vstar database service. So what I'm going to use now is, for sort of the slideshow part of the presentation, is an iPad, somehow miraculously, wirelessly going to some other part of the building, connecting back to the server, which is just serving up very simple web pages, which are sort of the slides, the points that I'm trying to cover. So now I'm hoping, I believe this should be readable, but one never knows. So I'm going to just sort of, I would like to finish early, so I'm not going to labor each of these points. But basically, Vectornova is the company. It implements, distributes, and supports Vstar, which is a database system. It's similar in many ways to any of the other database systems that might come to mind. I've listed just a few of them here. But there are some differences. I mean, if there weren't, there would be nothing to talk about, that might be of interest. One of the points I want to emphasize is that although new to me, Vstar, and undoubtedly new to all of you, it's actually been in continuous development by this company in Mexico for 10 years. And it's been in serious production situations with very large databases for well more than 6 years. So this is not a new company. or at least not in the IT world. It's not a new company, and it's not a new product. It's a relatively mature, relatively sophisticated product that's gone through a number of generations. So the product, which is sort of getting near to shipping now, is version 4. So we call it V4. Let's see, okay, so we'll now try to go to the next page, see how that works. Okay, so just a couple of buzzwords, and I'm going to be around the rest of the conference, so I'm not going to be going into a lot of detail here, but I'd be very happy to answer any questions. I'm very approachable. But some of the buzzwords are, the key emphasis of the whole development has been on high performance. That's achieved largely through a columnar approach to data, which is nothing new to the APL or J communities. I mean, we've been inverting tables, fully inverting tables for, for many, many, many decades. But in the database, relational database technology, this is like they're just discovering that in the last few years, it seems. The other thing is that the thing that really made the development of Vstar possible were two things. J, as an underlying array manipulation language, APL would have done just as well. The second part was 64-bit operating systems, which, as the previous speaker pointed out, gives you the address space that you need to work with large, very large amounts of data. And the third part, which is the part that J provided, was what we call, which is memory mapping. And that's a facility provided by the underlying operating system and hardware, which basically says that a column of data, 500 million rows, a billion rows, a column of data is in fact just a noun, just a variable in the J session or an APL active workspace. So that greatly facilitated and enormously simplified the development of this database product. The other thing is that there are a lot of hot new databases out there, and there's one very well-established one very well-established database, KX, which have really focused on sort of market-type data. So some of the characteristics that characterize that kind of a database application. We see Vstar as being a much more general purpose, it's much more targeted at more typical business data applications than the specific characteristics of market data. And it supports sort of an SQL. Now at the time, this is something we're probably going to change, but our preferred interface to the database we call VSQL. Now, that name really came about several years ago when sort of saying no SQL or not SQL or different from SQL was a showstopper. That killed any, you couldn't carry on the conversation. Now, in the database world, no SQL, not SQL is becoming very, very acceptable. So we called it VSQL to not distinguish it too much from SQL, but I think we maybe need to go back and make that word a bit more different than SQL. One of the things that characterizes the product, Vstar, is that it's completely open source. That you have to take some options to achieve that complete open source, but there are no black boxes. And some people that's very important to, a lot of people that's irrelevant. The key thing about Vstar is that it is built entirely in J. So you have a J engine, and then on top of that you have the application level, which is the implementation of the database. And I would say that from the ground up, Vstar was developed, starting 10 years ago, with what I would sort of call the APL mindset, which is very, very similar, essentially identical to the J mindset. It's the way we think about data. It's the way we think about functional transformations of data. And this is reflected from the ground up in the design of Vstar as a database. I think I'm seeing conference fatigue out there. I think we need, this being a baseball town, we should all do the 7th inning stretch, but I'm going to barrel on and finish ahead of time. The next few slides are essentially a case study with sort of what I would sort of, the premier reference client for Vstar. This is our RZB. And like all banks, they keep changing their names because they keep acquiring and changing their names, and sometimes they try to look like a local Austrian bank, and other times they try to look like a global, worldwide megalith. But anyway, for the purposes of this, they're RZB, although that's no longer their proper name. But RZB was the name that they had when they presented a paper at an open database conference in 2008 in Europe. And so what I'm presenting on these slides are essentially just lifted, slightly paraphrased from the document published by RZB. So the there we go. Okay. So the problem that RZB had, sort of in early 2008, was they had, and again, I'm getting into some banking jargon, which I have to admit I don't totally understand, but they had a value at risk. They wanted to do a certain, so they had all this portfolio information, stock holdings, et cetera, and they wanted to do a value at risk to do the risk management of it. And they had 15 billion net present values in their database. And two things, they needed to essentially aggregate this company-wide on at least a daily basis so they knew globally what their risk exposure was. But probably more importantly, they needed individual teams throughout the world to be able to do their own value at risk analysis of their own subset of that the total global portfolio. And so they had a database problem, 15 billion values. They want to aggregate them totally. They want to aggregate them in according to various subnodes. Very straightforward database application. And so they tested a couple of different approaches, basically starting with their traditional preferred vendors that were already well established in-house at the bank. All name brand people. But one of the things you find out about databases is that the name brand people all have agreements where you can't talk about them in comparative benchmarks, et cetera. So these will be the traditional database vendors. Shall remain nameless. Where are we at? Seem to have lost my
thinking.
Loading. It's loading the story too.
No, I seem to have lost my connectivity to the wireless network has gone down. Curses.
Well, maybe your server has timed out.
Let me, rather than fiddle with this, I'm going to, this is a real nuisance. I'm going to try switching from this.
Is your server, it's not your server that has fallen asleep?
Oh, maybe. Oh, you're absolutely right. Thank you. I'm not used to these damn boxes that are smarter than I am. You know, they sort of, you ignore it for a few minutes and it goes to sleep. You ignore it for longer than that, it goes into hibernating mode. Anyway, I think we're back in business. Thank you.
Yep, yes, you go. Yay.
Yeah, that looks different. Okay, so where were we? Oh, yeah, so the bank is doing benchmarks, and they set up a series of tests which they were going to evaluate essentially their in-house traditional database management systems. And we'll jump ahead one slide here and say that the traditional approaches that they looked at, essentially the aggregation time for the test, which was just a subset of the 15 billion values they had to aggregate, was 2 hours and 46 minutes. And they realized that this was a non-starter. This was not the solution they were looking for. And so they reached out and did, sort of the Google search and I think quite by accident, stumbled across the Vstar product in Vectornova, invited them in, and 2 weeks later, Vstar was demonstrating the exact same test with less than 2 minutes of the test time on, and this was the part that actually knocked the bank over the most. They demonstrated the under 2 minutes on completely standard off-the-shelf hardware. The same computer that they would have gone down to their corner store and bought, rather than sort of a very expensive high-end server, which was being quoted by their traditional database vendors. And the complete application was finished in Vstar in less than 2 weeks after they had passed that proof of concept. And the other thing that the bank was extremely pleased with, and quite happy with in this presentation to the Congress, is that this solution was then trivially encapsulated as a web service, so that the way they could then provide this worldwide through secure web interconnections, that a user from across the world could fill out the form, send it in as an HTTPS request, get back the result, and have it be fast, have it be reliable. Okay, so I'm going to, if I can keep my, maybe I should poke it once in a while.
Yeah.
I'm going to try to do a demo now that's very, very loosely based on the RZB example. I mean, it's obviously fake data, and the aggregation algorithms, the way they calculate the value of risk has completely changed, but it's a sense of what their application was. There's things here. One of the things that I think is really interesting, I mean, it's not unique to Vstar, and I think it's becoming common in new database technologies, but it's quite the opposite of the traditional approach, and that is the mapping of the hardware layer, the mapping from a file, the mapping from a file folder. So a file folder is your collection of databases, and then the database folder in that is a collection of folders which are your tables, and then the folders in that are the data relevant to a particular column. And in fact, then a column of data is just a flat file with binary data in it, but it's just a flat file. And so the mapping of what you think of as the database schema onto the good old file system is very, very direct and very, very simple. And there are many, many benefits from this that I'd be happy to talk about separately. So in this sort of toy example, which I have running on this laptop, we've got a table with 10 million rows, and there are a couple of different columns. But the key columns is there's a portfolio ID. So normally, it's a 500 character wide column. Normally this has all kinds of information that makes sense to the bank. So it's a portfolio number and all kinds of, who originated it and where it comes from and what its history is, all encoded in that 500 characters. And so what we're going to do is, in this very simple demo, is basically in the 10 million rows of that 500 character column, do very simple lookups. I've got to figure out how to stop that from happening. To do the demo. So the laptop is a sort of a low-end dual core, but it does have a little bit more memory, because one of the things that characterizes Vstar is it makes maximum use of additional memory. So the way to make Vstar run faster is to give it more memory, as opposed to, say, more processor power. Although more cores are always nice. Okay, so I'm going to demonstrate with two very simple queries, which are essentially put up as stored procedures in the Vstar database. So the first one is simply saying, give me a set of these portfolio IDs and give me back the net present values. So in fact, the interesting thing there is that the net present value column is in fact an array. It's an array in exactly the way that an APL user or a J user would think of. It's not, you don't have 50 columns of separate numbers, each with their, names like column 1, column 2, column 3. The column is in fact an array. So I'm going to demonstrate 3 different ways of getting this. One is like just through a web browser from this device here, and then more the way sort of like a power user would use it, sort of directly from the machine with a direct connection into the database, kind of more the user who would be developing procedures which are used by end users. Okay, so I'm going to try to turn this into a database person. So I guess I've asked for my bookmarks on the iPad for the Safari browser. I'm going to ask for the database bookmark. Okay, and again, this is just a trivial HTML form. It has 2 fields I fill out, and when I send the request, it sends an HTTP request to the database server over there, and gets back an answer. So the first field is the portfolio ID, which in this demo are just very simple. No, I'm sorry. The first thing is in fact the procedure, what it is we want to do, and that's going to be. Let me see. So it's going to be a selection request, and I'm going to ask for a couple of random portfolio IDs. And it sent a request to the database. It looked those up in the 10 million rows, looked up those two PIDs in the 10 million rows, got the present values for those 2 rows, and returned an array of data, which are the net present values for those 2 PIDs. The other one, which is just slightly more complicated, and that is it's actually doing sort of an aggregation. It's taking a bunch of PIDs in various nodes and doing a complicated statistical evaluation of them to return the value at risk. So the first thing I give here is the name of sort of the collection, the sub-collection that I'm doing. I mean, initially, obviously in a real application, you wouldn't be typing this in. The node would already be a defined thing, probably from another database, which said these are the portfolio IDs. But I'm just typing it all in manually here. So that would be and I can give it another node name and some other portfolio numbers, and say go. And so again, it sent just that request information through the HTTP, gotten back the answer, and there's many more calculations that it does, but it returned this number of calculations, and those calculations aggregated those PIDs for those 2 nodes. Okay, pretty good. So I'm going to switch off of that guy now and see if the laptop is still talking to us. Okay, the first thing, let me get back to, okay, I'm going to skip this part. At this part, what I was going to do, but I'm more focused on finishing on time. At this point, what I was going to do is essentially say the server is running the database there, and so any of you with your laptops could browse, if I gave you the IP address, could browse and do those same selection and value at risk inquiries that I was doing. And also, if you had an APL workspace, if you fired up Dyalog APL, loaded, I think it's a fairly standard utility in Dyalog for doing HTTP requests, GET requests, wget, you could then fire in a wget request and get the data back again as a floating point array in your workspace, straight from the thing. But I would be happy to show that sort of offline to anybody, but I don't think it's necessary in the course of the presentation.
So what are we up to?
Okay. The target audience, the kind of clients that Vstar is interested in, is more than sort of, there would be a relatively small number of what we would call sort of power users. These are the people who really understand the database. They're the domain experts in whatever it is that the data is about. And they're the ones who are meeting the end user requirements of the end users say, well, we want to know these kind of things. These are the kind of queries we want to be able to fire against the database. And so these power users, with their knowledge of the database and what the end users want, are putting together procedures. I mean, these are not really procedures in the same sense as stored procedures and SQL, but it's the same idea. It's essentially the set of steps necessary to fulfill the needs of that user. So the power users are essentially, their connection to the database is much tighter and much more interactive, and it's what we would call stateful. So the power user typically would work sort of, he can sort of say, from this database, from this table, where this, and oh yeah, but now I want to throw in this where. And so the state is progressing as users go. But at the end of the day, he ends up with a procedure which is then wrapped up that can be used in a stateless manner by an end user out at the end of an internet connection. So the power users could be an APL user in an APL workspace developing a procedure that runs on the database system. But the real focus of Vstar is not, we want to make life as good as possible for these power users, but that's not the focus. The focus is how do you support thousands, hundreds of thousands of end users all around the world. So the key thing to Vstar is that the front end, the real contact with the outside world, are things like Apache, Nginx, which is sort of an Apache, much simpler Apache equivalent from out of Russia. Node.js, there are several, and they're coming more and more of these things. But they're all basically web servers which do things like load balancing, some security management, etc. But at the end of the day, they get in their request, they do their load balancing, they find out which machine to fire it to, and that's the database request. And then the database response is formatted however the application wants it, and it comes back through that connection. But Vstar is not sort of typically the front-end interface to the rest of the world. It's some web server like Apache. And part of this is that what we're trying to say with Vstar is that it scales with the number of rows. So Ernesto, the chief technology officer, his attitude is that life doesn't become interesting until about 500 million rows. And then it goes up to 1.5 million rows on standard hardware, 1.5 billion rows, I'm sorry. These numbers are way bigger than I'm used to. Okay. He doesn't get excited until 500 million rows, and up to like 1.5 billion rows, he'll do that on sort of fairly standard hardware. Beyond 1.5 billion rows, you start to get in more specialized hardware, more specialized operating system tweaks, and more specialized additional layers on top of the file hardware that exist at the operating system level. And because it's a columnar database, the total size of the database doesn't matter. What matters is that you can do your queries, your where selections very quickly on the columns. But then if you have other columns, which are large arrays or PDF files or fingerprint database entries, it doesn't matter how many terabytes are in the total database, because the search time is simply a function of the number of rows in the column and the data complexity of the row. And in this example of the PIDs, that data complexity, it's done with a hash search. So even the data complexity tends to fold in to the high performance. And then the other direction of scalability that we wanted for the product is for the number of users. So just that, we're looking at a very large number of users spread around the world, through stateless connections through the internet. I just have, well, I'm just going to jump ahead to this. I'm supposed to be someone in a sales role now with this company. Because quite frankly, they don't have anybody else who's capable of doing a sales role. So what we wanted to talk about is that possibly, I mean, this is a real stretch on our part, is that a community of APL users who share sort of this APL mindset that we say was so fundamental in the development of Vstar, it might make such an audience, at least one or two of you, perhaps somewhat more sympathetic to this kind of an approach to databases. So what we'd like to do is we'd like to offer, limited time only, to Dyalog APL users what we would call a proof of concept. And this is typically how we got the bank business and how we would deal with other clients. Basically, you provide us your sample data. We'll load it on one of our servers. We'll provide procedures for doing the typical kind of queries you'd like to do. And then you can just try that. And if it piques your interest, if you like the performance, if you like sort of the cost equations for the hardware and the software, then we can sort of move to the next step of a license in-house. And the other thing is that as a new, not as a new company, but we're still sort of the new kid on the block. We are very, very interested in reference sales. We're very interested in clients, especially in North America and Europe, that we can use as, it could be a success story, so that's good for you. It can also be used as in some sense, a reference site for our attempt to push this out on the world. That's it. I have time for some questions or no questions.
So this is mostly, from my understanding, this is like a data warehousing kind of an application where you're not getting too much data in the data.
No, okay. It's, maybe I skipped over this. It's a complete database system. It has everything you want. It has, it has joins, it has update, it has insert. It can support multiple concurrent users. It has, interlogs, it has commit and rollback. It's a complete general purpose database system. It's not just a data mining tool for one user. We would say, any typical business arena that Oracle, DB2, any of those guys would go in and go for, we will say that we will meet and exceed the requirements, especially in the arena of performance. So it's not a specialized thing. It is general purpose. And it is a database system. It's a relational database system. It's not a special data mining tool or any of the other sort of niche areas in databases.
Is your performance benchmarking focused on reading or what about writing?
I mean, that's one of these catch-22 questions. I mean, it's focused on the appropriate balance of those two things. You need to be able to very quickly service lots of inquiries against the database. But you also need to be able to service lots of new data coming in, whether it be inserts or updates. So we're trying to strike a balance for that. I mean, I think like any database, the balance tends to be towards more reads, more references than writes. But we're trying to strike the balance there. So no, we would, that would be part of a proof of concept that you would do with us. You would sort of say, here's the CSV files, here's the schema, here's the type of procedures, and those procedures can be, and we want these procedures run at this rate, and we want, this kind of insert rate, this kind of update rate, we want this kind of read rate. And there's also some of this is catered to by different strategies. So for example, updates typically can be done so that they're destructive or non-destructive, and there are sort of benefits both ways. But that's a choice you can make in setting the database up.
Technically, I was wondering what the differences and similarities are between J and KDB.
Well, not between, I mean, between J and KDB, I mean, K is a language and J is a language, so we can compare them. But we compare Vstar with KDB. You know, I'd say, you know, the biggest difference is that KDB is a phenomenally successful product that has pretty much tied up its own little niche market, which is, you know, extremely high performance market type data. So we would, you know, so if we were doing our sales pitch, we would say we're nearly as, we wouldn't pretend to be as fast as KDB. We don't need to be, because it's an order of magnitude or more or three more expensive than Vstar.
It's in memory.
So we're not, but we are trying to look at the same scale, the same, you know, number of records, but probably with not quite as good performance, but a lot better price performance. And we're also looking at not quite such a specific type of data and not quite such specific patterns of usage of the concurrency of reads and writes versus updates.
Well,
Yeah.
the question, phrased it well enough, but I was really getting at the technical aspect, because K introduced two new data types, like dictionaries and tables, which were optimized for the market type data. And I think a table generally has a key like a stock name, which is
Okay, and this is probably a question.
I'm just wondering at the technical level whether you implemented special.
No, I mean, okay. The general answer to that is that, you know, we don't view our competition as KDB. We view our competition as all of the other guys. So we haven't targeted that specifically. But I'll be happy to talk with you that in more detail afterwards.
Yeah, I'm just curious, that's all. Okay.
What kind of
Well, then
applications-
hold that curiosity.
What kind of applications are you targeting? From, I mean, obviously you're trying to.
Anybody who'll use it. I mean, you know, large corporations with large amounts of data who currently, you know, they may be happy with their solution, but they're running into a performance brick wall. You know, they need the answers now, and increasingly they're getting them tomorrow. The other thing would be somebody who's finding that the database bill keeps going up and up and up because they need to scale up the hardware. And as the database grows a little bit, they have to scale up the hardware. And they start to get into some extremely expensive hardware to get the performance that we need. So part of what we're offering here, I mean, it was on that RCB slide, you know, Vstar ran 100 times faster than the competition on the same hardware. The competition could match the Vstar performance, but on a hardware software thing that cost 100 times as much. So we're not 100 times faster and 100 times cheaper, but you can have your pick. And so one of the targets, business-wise, would be somebody who doesn't want to multiply their combined database software and hardware costs by 100 completely unnecessarily. And that all goes proportional. And if you have that kind of an operation, you need that many more database admin people, et cetera, et cetera.
So
There.
outside of the implementation with the Austrian bank, what other types of applications
Okay.
do you have?
It's a Mexican company, and it started there more than 10 years ago. And you know, the overwhelming majority of their clients are in Mexico, and although they do have clients in other parts of South America. And in Mexico, their overwhelming clients are governments. So it's the federal government and the state governments, and it's things like, you know, vehicle registration databases, police information databases. So one of the applications they talk about is, you know, so every police officer, and this was back sort of before the narco war started, so it's changed a lot. But every police officer will have a keyboard in his car, and that was an HTTP request, well actually a wireless request, which got converted into an HTTP request to get information on, who was this car registered, fingerprint and where the guns are, database like that. So it tends to be sort of government-type, large databases, which tend to be on, typically people, human resource type databases. One last question. Yes?
I can see how maybe some state governments might.
I'm sorry, you'll have to speak up. My hearing's not the best.
Some state governments might be attracted to this, but they're not going to like buying software produced in Mexico. They're going to be supported.
No, I don't think we're not targeting the U.S. state governments as our primary sales target. I mean, I probably missed the point of your question.
Well, even a large corporation might not like.
No, well, then those are ones that we won't talk to. We'll talk to others. No, I mean, it's an unfortunate fact of life that we'll figure out how to deal with. Well, I'm from Toronto, which I'm not,
So what
maybe
is
some
your
of these
role-
guys don't want to buy from a Canadian company either.
What is your role within the
It's a very small company, sort of less than a half dozen altogether. I'm a partner, sort of in an ownership position. I've only been there for a couple of months, so what my role is going to be, I don't really know. Sort of this conference here was I viewed it as sort of like a, old home week, somewhat of a friendly audience, a little bit of a practice, listen to myself speak. Okay, we're out of time. Thank you very much. Coffee.